Hi, everybody. I'm Steve Green. I'm a director at Oracle Labs in Burlington, Massachusetts, which today is about a 95-minute drive from here. Oracle's lawyers make us give this safe harbor statement whenever we're giving a talk. It basically says, like, these are forward-looking statements, and you can't really trust them. And if we don't do anything that we say in the presentation, it's not really our fault. So I'm with Oracle Labs, so we use a slightly different version. Really don't believe any of this stuff. This is all research. We are a real research lab. We're not some kind of show pony that they just have so that they can say they're doing research. And I'm hoping to actually convince you of that a little bit today. This is a picture that my senior vice president took this year at Oracle OpenWorld back in October. That's Larry Ellison, the founder of Oracle, for those of you who don't know, standing in front of a slide that says, machine learning is a technology as revolutionary as the internet. So if you want to ask about whether Oracle's serious about machine learning, I think the answer is a hard yes. At OpenWorld this year, I think there were 100+ sessions where machine learning was some component of the session. So Oracle's betting big on machine learning. Oracle Labs is one of the many sources of innovation at Oracle. We don't claim to be the only place that innovation happens at Oracle. We're doing real research, as I said. We're not some kind of weird PR vehicle. We're about 200 PhDs, masters, and bachelors of science. As you can see from the map, we're spread all over the world. We're the dot that's here in Massachusetts. The main part of the labs is out in California. We have outposts in Austin. We have outposts, quite a large one actually, in Brisbane, Australia. And we engage in research on a wide range of topics. And the mission of the labs is straightforward: to identify, explore, and transfer new technologies that have the potential to substantially advance Oracle's business. So this gentleman here is Edward Screven. He's my boss's boss's boss, and he's the chief corporate architect for Oracle. Oracle Labs actually came out of the Sun acquisition. For those of you who fondly remember Sun Microsystems, I hope at least some of you remember Sun? Yeah, okay, a few nods, thank you. And when Oracle was acquiring Sun, they decided that they were actually going to keep Sun Labs because they wanted some place that could cut across all the stovepipes, all the silos in Oracle, and actually help figure out how to do things better, right? Actually do research to figure out how to make Oracle's products and services better, and that's what we aim to do. Generally speaking, when the lab selects a project, it needs to be connected to the business, right? So this is not some sort of pure research operation where we can do whatever we like and it doesn't really matter if it ever gets into a product. It really needs to be connected to the business. There needs to be some path by which we'll transfer that technology into the business groups. And it has to be something that engineering can't do by themselves, right? So the engineering groups at Oracle are busy producing the next version of the products that they work on. And really, they don't want to do things that are too risky, that might not work. They don't want to do things that will take too long. And they want to make sure that the scope for the projects that they undertake is realistic. In the labs, however, we can really start to play with all those things. We can do things that are risky, that might not work. We can do things that are going to take sort of 3 to 5 years instead of thinking about the next release. And we can think about things that are really out of scope for Oracle products. We can look at things that we think maybe Oracle is going to have to be considering sometime in the future. So that's kind of all of labs. What about my group? So I run this thing called the Machine Learning Research Group. It's a pretty good name. I mean, it basically does what it says on the tin, for sure. We've been doing this for about 7 or 8 years now at Oracle. Previous to that, I did a lot of research in information retrieval and sort of applications of natural language processing to information retrieval. And when we started doing this, the vision that we had and that we were supported in by Edward Screven, the guy whose picture I just showed you, was really to figure out how to scale machine learning across Oracle. So at the time, we were sort of a 5-person group. Oracle is a 150,000 person company. This is kind of a big ask for 5 people to do, but we've been going at it pretty diligently. And of course, the world kind of changed around us as well. Back in 2011, 2012, we would go to some Oracle business group and say, hey, there's this thing called machine learning. It can help solve some of the problems that you have. And people were a little bit skeptical and they didn't quite understand it. These days, people show up to us and they say, I need deep learning in my product. And you say, do you know what deep learning is? And they say, no, but I absolutely need it in my product. So, we still have some of the same roles that we did a few years ago. It's just that we're seeing more pull now than push a lot of the time. So what are the kind of things that we do? We acquire and build tools for machine learning. right? We want to make sure that Oracle product groups have the tools that they need to be able to do machine learning. We understand what all the open source tool sets are. We understand their strengths and weaknesses. We're building tools to fill in the gaps and that address needs that aren't handled by the community. So for example, the state of Java machine learning tools is a little bit worse than the state of things in Python, for example. So we're responsible for kind of a Java equivalent to scikit-learn that we use internally with a lot of the product groups. We manage data acquisition and storage. This is a big one that we've been working on for about 5 years, managing this thing called the Oracle Secure Research Data Repository. The idea there is that we recognize the need for data as a core part of machine learning, and we started 5 years ago now, I guess, to actually make sure that there was a place in the company where we could get the data that Oracle has and data from its customers from time to time and put it in a central location that could be used to do data science and machine learning on that data. So it's not just a place for storage, it's actually compute that we can use and apply to that storage so that people can do machine learning and data science. We've been building a machine learning community at Oracle. So this is sort of our outreach role. We run Slack channels, we run mailing lists, we run an annual machine learning summit, internal machine learning summit. I think last year we had around 400 people out in California to see the summit. This year I was talking to my SVP and I said, so are we going to get to run the Machine Learning Summit again this year? And he said to me, you're required to run the Machine Learning Summit again this year. So that's kind of where we're at. There's definitely a lot of stuff in here. We build proof of concept systems for groups inside of Oracle, so we collaborate with Oracle's product groups to try to figure out how to use machine learning to solve their problems. And part of that, as you can imagine, is building systems that do the things that they want us to do. And because we're an industrial research lab, we really need to do it in a way that they can use, right? So it's no good to them if we build a great model that takes 20 minutes to run on one example. It needs to run to the kind of scale that they need it to run. And we also give them a lot of advice and evaluation of options that they're trying and that sort of thing. So collaborations with my group can be big ones. So we've had a collaboration with Oracle's sales operations and marketing operations team that's been pretty deep and ongoing for about 2 years. We have multiple meetings every week. We're building things for them that they're putting into our marketing systems and our sales systems. And then there are people who just want to call us and talk to us for an hour. Even people who are relatively skilled in machine learning, sometimes it doesn't hurt to be able to call somebody and talk to them, talk to somebody who has a PhD in machine learning for a few minutes to help figure something out. So our team is sort of divided into four pieces. They're presented here linearly because that's how text works, for those of you who don't know. But it's more like overlapping centers of gravity, right? So each of these teams kind of interacts with the other in order to pursue these collaborations and our own original research. So we're called the Machine Learning Research Group, but we actually have what we call the core research team inside of it, who are tasked with pursuing like actual, novel research in machine learning, the kind of thing that you could get published at NIPS. And indeed, most of my research team is actually up at NIPS this week. We have a data science team that's run by Palika Kanani, who's actually here today. You can go visit her in the Oracle booth if you like. The data science team is really tasked with pursuing those collaborations, making sure that the product groups are getting the help they need to build the models and understand the techniques that they need. We have a software team that's building these tools and enhancing them, sort of releasing them and versioning them and doing all the kind of things that a good software engineering team does. But because we understand how to build the tools and a lot of places don't, we've sort of taken on that responsibility. And we have a data team that runs our data repository. They're responsible for inbounding, making available data sets inside the company. And Oracle's a big company. Oracle's lawyers are a little bit paranoid, or possibly a lot paranoid, depending on who you ask. So the data team spends a lot of time making sure that the lawyers understand exactly what we're trying to accomplish here. And over the past few years, we've done a lot of good in sort of smoothing the way for teams that want to use data to do machine learning at Oracle. So our research interests, kind of broadly stated, are core machine learning. So these are sort of fundamental things about machine learning. So for example, we do feature selection and causal inference, which are kind of core machine learning concerns that cut across a huge swath of machine learning applications. Talking about scalable inference techniques, active learning, and unsupervised techniques. We have kind of a specialty in statistical natural language processing. I'm actually a computational linguist by training, although back when we did it with rules and not statistics. And we've undertaken a wide range of natural language processing projects over the past 5 or 6 years. pretty much all the things that you would think of in an NLP stack: named entity recognition, entity linking, relationship extraction, sentiment analysis, all this kind of thing. One of the things that we're really starting to focus on now is fairness and transparency in machine learning systems. This is something I expect that all of you have encountered at least a little bit, and is starting to become more and more of an issue. For companies that are producing AI systems, you've all seen the headlines about Amazon getting in trouble for its hiring model and all this kind of thing. And so we're pursuing this as a research problem, as well as trying to help our product groups understand how to apply these early efforts in fairness to the systems that we're selling. And of course, there's this whole question around interpretability in ML systems. You know, if you give somebody a decision based on a machine learning algorithm, how do you explain that to them? And that turns out to be, as I'm sure some of you here know, a pretty difficult thing to do. I'm not sure how much my team appreciates it, but I'm kind of a skeptic on the whole current state of explainability efforts in machine learning. It looks an awful lot like trying to explain a decision tree with a paragraph of ands and ors and a bunch of numbers, and I don't think that's actually very useful. So we're tackling that. And our research is founded in the collaborations that we're doing with our team. So for example, we're working with our sales team on trying to figure out which leads to pursue. And so the explainability work that we're doing, we're pursuing sort of fundamental research, but it's in the context of helping the sales reps understand what the model that's doing lead scoring is doing. Whoop, that was the laser. So machine learning at Oracle, if we had to kind of boil it down. So we're not the only place in Oracle that's doing machine learning. But we're one of the places where we're sort of doing fundamental research, and we're trying to help the other teams that are doing research. And you can probably guess this, we want to apply Oracle's knowledge and data to solve business problems that matter to our customers. So we're not necessarily interested in building Go-playing robots. I mean, all that reinforcement learning at work at Google is super interesting. But if I go to my boss and say we built something that can beat AlphaGo, I think his response would be, you did what? And what about all the interactions that we had? And I would be in big trouble. So we need to understand how to apply machine learning to provide a business benefit, and try to understand what algorithms and data to use to get to a particular goal, right? So we're not just out there pushing the latest deep learning thing because it's cool and we might get to publish a paper at NIPS. We're trying to understand, is this the kind of problem for which you could use logistic regression profitably, and how could you use it in the context of what you're doing? And how could we explain it to your users? So that for us is sort of this fundamental aspect of machine learning that you don't necessarily see in academic work. And we want to build products, services, and platforms that give our customers the opportunity to build and deploy their own machine learning systems. So I think if you went to the talk yesterday at Matt's talk, he sort of talked about putting AI into our SaaS platform. So Oracle sells a whole bunch of products. If you don't know much about Oracle, there's a lot more than the database. We sell all the products that help companies run their own businesses. We're doing all that in the cloud now, and our aim is to take all of this AI, all of this ML, and put it into those cloud products to help our customers do a better job of running their businesses. And we're helping the teams that are doing that by doing this fundamental research and pitching in on some of the collaborations. So, all right, so I just sort of said we didn't want to do all this cutting edge stuff and jam it into our products if we didn't have to. So why do we even want to do machine learning research at Oracle? Why do I have a job? Why do Palika and Haniye have jobs? And the answer is that even in the context of business, you encounter problems that are not addressed by sort of academic ML and the current state of ML research. And you need to have the capability to do that research yourself to solve those problems. So this is actually an actual example that came to us a few years ago. We acquired this company that had these user profiles, and it had about 3 billion of them. And what it wanted to do was to easily be able to tell two customers who were similar in order to build audiences for advertising. So we showed up to talk to them, and they were doing things like sampling a few thousand and trying to cluster those. And the fundamental question was, why can't we just cluster all 3 billion profiles? And at the time we asked them that question, there was just no way to do that with the extant abilities for doing this with this technique called topic modeling that they were interested in. So this thing over here, just to make me look smart, I put up a graphical model. This is the thing that was popular before deep learning took over the world. But the basic idea behind topic modeling is that you cluster items and represent them as a vector of k topics. And each item is kind of a mixture of topics. So you can think about it in terms of a document and words, if you like, where each document is about a few things, and it tries to figure out what those few things are. And then if you've reduced all of these items into this k-dimensional space, you can very quickly compute similarity between items in that k-dimensional space. There actually are well-known approaches to building these models if you're talking about thousands or perhaps tens of thousands of items. But when you start to look at the scale of 3 billion items, all of a sudden you realize that this will take multiple years and tens of terabytes of memory. So if you're lucky enough to have a computer that has 10 terabytes of RAM, you only have to keep it up and running for about 4 or 5 years to build a topic model at this scale. And we didn't like our odds very much. And the other problem was that they needed new user profiles every month. So every month they would show up with the 3 billion user profiles, and they would want this condensed representation. So what were we going to do? We could try to parallelize it onto a huge cluster of computers. That might help. We could look at the open source implementations. But what we did was actually try to take a look at the computational underpinning of topic models and try to figure out how we could redo topic modeling, look at the fundamental statistical properties of the algorithm, and actually rebuild it so that it could be parallelized. And what that means is uncovering and exploiting parallelism in the model itself. So actually looking at the math for sampling and inference and trying to figure out exactly what's happening. Try different data structures, so looking at sparse matrices versus dense matrices, or perhaps a mix of them depending on what the, what the particular stage of the algorithm needed. Use approximations. So one of the things that you're starting to see now in the deep learning world is people are starting to use shorter and shorter representations for floats because they can cram more data onto a graphics card. This is the same kind of thing, except we were using approximate counters. All these algorithms work by counting occurrences of things. We can use approximate counters and do a lot more on a single machine. And of course, we can try other architectures. So we could look at GPUs, we could look at distributed computation. But you can apply these techniques blindly, but what you need to do is deploy them without destroying the statistical properties of the algorithm, right? So you have to understand the statistics well enough that you can measure whether any of these modifications to the algorithm is actually going to break the statistical properties, and then you don't get good clusters, and then you can't build audiences the way that you need to. So just to give you an idea of what we can do here, we started looking at GPUs because, of course, this was, 4 or 5 years ago. GPUs were really starting to come into favor in machine learning. This is actually before a lot of the deep learning frameworks were invented. So we have a Wikipedia corpus of 50,000 documents. We were going to build 20 topics. That's our K. These things run in iterations, so you do iterations over the documents, and we ran 20 of those. If you just take the standard algorithm that everybody used, which is called collapsed Gibbs sampling, and you ran it on a regular old computer, just a CPU, it took about 6.5 minutes. So we were actually coding on a GPU using kind of one of the top GPUs at the time. If we just parallelize it in a straightforward way, we could get that 6.5 minutes down to 20 seconds. And using these kind of novel optimizations that I was talking about, we actually got it down to 5 seconds, which is about 80 times faster than it was. And in fact, Guy Steele, who was working on this project, used to work at Thinking Machines across the river. Does anybody, aside from me, remember Thinking Machines? Oh, a couple. Well, it turns out that a GPU is just a little tiny thinking machine. Guy actually went in and pulled algorithms out of papers that he wrote in 1981 for thinking machines to use to do this project. So, not everything old should be thrown away. But the thing is, once we actually figured out how to do this really quickly on a GPU, it turns out almost every optimization that we had included actually worked on a CPU as well. So on a CPU on one of our x86 machines, we could actually get this down to 10 seconds on a single node, which is about 40 times faster than the baseline. So we're actually processing 3 billion user profiles that have been assigned to categories that are selected from a set of about 150,000. So that's about 3 billion documents and more than 100 billion words if you think of this as a topic modeling problem. And the idea here is that the topics will give us ideas of the user interests, and we can calculate this user-user similarity. And we can train a 20 topic model for 20 iterations on 16 machines in about 2.5 hours. So you recall when we started looking at this, we were talking about years on machines with tens of terabytes of RAM. We can get that down to a couple of hours. So at the beginning of the month, on the first of the month, when you have your new user profiles, you can have your new user representation by about noon. And that's if you start kind of late, and you drink coffee, and you read the news before you start. So I was supposed to give the, I'm up here talking about labs because that's my thing, and I like to talk about it, and I get excited about it because it's a pretty sweet gig. But the fact is, we're trying to transfer these things into products. So the question that you might have is, where are we putting this? There's this thing called Oracle Advanced Analytics. I think they're starting to call it Oracle ML now. This is actually a toolkit that's been around for almost 15 years. It actually also came out of Thinking Machines. Sun Microsystems bought the hardware part of Thinking Machines, and it turns out Oracle bought the software part of Thinking Machines, so they were finally reunited. So Oracle Advanced Analytics, these are the algorithms that run inside the database that Matt was talking about yesterday. There's a huge suite of algorithms that run inside the database. They can run in parallel on rack configurations. It's actually an amazing amount of work that doesn't get the credit that it really should. If you have data in an Oracle database and you want to do machine learning, you really should be thinking about Oracle Advanced Analytics. It turns out the team that does Oracle Advanced Analytics is in the Boston area. I'm sure if you had questions about how to use it, they would be happy to help you. And of course, this is not some static thing that they designed 10 years ago. This is a living product. They're actually updating it with new algorithms. They have a hard task, which is that these algorithms have to run on clusters of computers. So things that you just pick out of a paper and try to implement, you need to do a lot of engineering to actually get them run inside the database. The other part here is actually the Oracle Adaptive Intelligent Apps. These are the folks who are doing the machine learning that's going into our SaaS apps. So they're basically trying to, in fact, some of the things that we've been working on, they're trying to take it and embed it in our SaaS apps so that our customers can take advantage of it the same way that we can. So they've been working on things like next best offer, next best decision, that kind of thing, next best action. And these are products that are shipping today. So you can, if you want to find out more about it, we're in the booth over in the far corner there. You can come and talk to us and find out all about it. Thanks very much.